Good evening, everyone. How are you? I hope you're well. I hope everyone's doing all right there. We've got a couple of slides to share with you from CNC Robotics. I'll make a quick introduction to myself, and then Julia, and then Michael. I'm Jason Barker. I'm owner and CTO or founder of CNC Robotics. Had quite a vast experience of robots over the years. Myself personally, being an artist and a sculptor, came from the creative background, so I'm slightly different than the normal IET members that you might see coming from an industrial world. But having said that, there's quite a lot of interesting things we might be able to share this evening, so strap in. Over to you, Julia.
We're going to wait a couple of minutes as well now, just to allow all the attendees to come and stuff like that. We'll probably kick off the actual presentations and talk at 5:05. Obviously, Jason and Julia will do the main bulk of the presentation at the start, and I'm going to obviously follow up from the rear end of the presentation, just to obviously let everyone know how they can obviously obtain any CPD certificates, and obviously give a bit more of a brief overview of the manufacturing and management group, who's obviously kindly organised this event today with CNC Robotics, how you can be involved briefly, and obviously who to contact if you're looking to be involved as well in the future. But we'll just give it a couple more minutes, and then obviously Julia can lead the helm.
Should I start now?
Just a couple more minutes, Julia.
Okay, no
and then we'll go with 5 past. We're currently at 46 participants. So we're getting there. I don't know what the expected numbers are, but I assume we can give it another minute or two, and then we should be good to go.
Had your dinner yet, Michael?
In the process. Okay, we just got one more person joined.
Work in progress.
Work in progress, yeah. Work in progress. Okay, we seem to be pretty consistent and steady on numbers there, so I think we're pretty much good to go. I'm going to turn my video and mic off, and obviously I'll catch everyone at the end. Okay, over to you, Julia.
Okay, so good afternoon, everyone. I'm Julia Núñez, and I work from CNC Robotics as a business development. My experience had been in international business and commercial side. So I just joined the company to help them grow and keep with their innovation. And I'm looking forward to answer the questions at the end of the session. So Jason, if you want to start.
Yeah, sure. So a quick introduction for those that might have missed it early on. I was quite quick off about there. I'm Jason Barker, owner and CTO of CNC Robotics. Over 10, 15 years of experience in the robotics industries, specializing in machining with robots. A previous life of mine was the entertainment and the creative industry. So I've come from a slightly different background than a lot of the engineers that you might see working with robots. The introduction or at least conversation today is more to do with what give you guys an insight in what we do and how we do stuff, with our focus being predominantly on the machining and more recently the additive side of robotics. Quick overview, I think, is good. So over the years, we've been classed as one of the world's leading robotics integration company, specializing in robotic machining solutions. That's to say, we don't really work in the automotive industries too much. We don't work in the pharmaceutical industries. We tend not to do pick and place. Our focus is very more to do with the machining and the accuracy of path planning for robotics. Over the years, we've been nominated for a top 250 company for growth and innovation. And we like to say we provide advanced manufacturing solutions. Some of our customers like us to provide some research and development services, especially for some new processes and new way of working in the general manufacturing industries, and that almost always becomes a bespoke or turnkey robotic system at the end of the project. We work quite closely with our customers and make sure that, at least from a process point of view, that we try and get stuff right first time. Of course, that doesn't necessarily go every time, but that iteration and working together, at least with the customer from a collaborative point of view, make sure that we tend not to provide that that problem solving part of our business is quite key. Just one moment. We integrate man-machinery technology. People have coined the term Industry 4.0. In our terms, that's quite a loose thing, but the important thing for us is that the training and the backup and support of our customers is actually the key. We don't necessarily put robots in a box and ship them. What we need to do, of course, is understand the customer's needs from a training point of view, and also that support point of view from the point of sale all the way through to that end of life of that machine or that system. The important bit on that backup and the support is, yes, it's great to have a robot on day one, but what happens to that robot on day 101 or day 1001? Over the years, of course, we've worked with lots of robot manufacturers, ABB, Staubli, Motorman, and in this case, KUKA. And we've become a platinum systems partner. And for KUKA, we sell more robots than any other integrator in the UK and have done for many years. And that's given us a good grounding as far as that support goes from our global partner KUKA. And if we do have customers outside of the UK and as far afield as New Zealand in some cases, then we do get that support locally on the ground because they're a multinational organization. Now, I talked about robots and accuracy and machining, and having co-developed some software with what was the company Delcam over the years, has now become part of the Autodesk group. And the key to the success of, I suppose, that CAD, CAM and advanced robotic path planning is, in the olden days and still today even, they used to program robots with a teach and learn directly on the part or directly in the process, and the offline programming has become more and more of a mainstay for a lot of the robotics world. Having that insight over 10 years ago for me was quite a challenge, and over the years I think there's quite a few, well, there's certainly more than a handful of companies that are now looking at, okay, can we develop a better robotic programming solution than is currently available? Again, that global support from companies like Waterjet does stand us in good stead for future installations. Client base, of course, is I mentioned New Zealand earlier, but across the world, the majority of our business is, of course, in the UK, and I think the numbers have switched over the recent years, and our friend Mr. COVID has played a good part in that, and I think those numbers might be more like 80% in the UK and 20% in the rest of the world. This slide being slightly outdated. It seems like from this slide, at least, we do lots of work in South Africa. It's not necessarily the case, but some of those installation bases have been spread across that continent. Some examples of some of our customers, and of course, some of you guys will instantly recognize some of these logos. It's not a screenshot of how good or bad our customers are, but they all tend to use our robots with good finesse to supply systems and products to their own customers. Some examples of what people can do with our systems. So they might want to turn a small thing into a big thing. You can imagine 3D scanning this part, applying the CAD CAM and toolpath data in PowerMill, the Autodesk product, and then the output goes straight onto the robot to produce what is a dinosaur, or whatever they're called. Of course, away from the creatives industry, which is to my heart, there's quite a lot of work that we do in the marine sector, and this particular installation's in Bahrain. A 25-meter track with a robot on it is quite good for producing the sides and plugs for molds and things for boats. And the use case in this, of course, is well, can you machine on one side of the track? Yes, of course you can, but can you machine on both sides where that operator is stood in that center picture? The other answer is yes, of course. So then you can set up two systems simultaneously at the same time. Of course, not just robots with cutting tools or milling tools on the end. We've done some waterjet systems over the past, and although a very aggressive and abrasive way of producing parts, it actually produces quite a very clean cut, especially on laminated and soft materials, where the cutter would generically try and tear or pull at the material. The waterjet cutting is quite a key thing, especially on roof liners for vehicles, that kind of stuff. We work quite a lot in the renewable energy sector, especially for composites. Got a couple of customers producing electric vehicles, other customers producing wind turbine blades, and that kind of stuff. And carbon fiber is quite an aggressive and detrimental material to cut, especially on a CNC machine where there's real issues with the carbon dust getting into the motors and gearboxes and frying control boards, where robots have proven themselves to be very good to work in hazardous or very dusty environments. Robots are almost impervious to dust, and the IP rating is quite good on those. So there's plenty of use cases where we've got robots machining carbon, Kevlar, those kind of materials. And in this case, the example would be to take a raw carbon fiber bobbin or reel of fiber and turn it into a finished product, using robotics as the vehicles to get them from A to B. I did mention we don't particularly do pick and place, but this involved also robotic machining as a secondary operation to the molding process. Of course, R&D is at our heart. We quite like the research and development projects. They're the things that gets us up, certainly me anyway, in the morning. And I'm quite pleased to say that our partnership with Autodesk meant we installed 2 robots. I don't think they've given them a name, although most of our customers give their robots a name. But these 2 robots sit in the foyer of the Advanced Manufacturing Facility, the AMF, at Autodesk in Birmingham. And if you guys if anybody's had the chance or the pleasure to go across to Autodesk, you would have seen these 2 right in the forefront of their operations. And the configuration of these has changed over the years. In some cases, 3D printing parts, cutting big fat chocolate bunnies, making a snowman, sweeping the floor, that kind of stuff. The robot at the back actually has got a chainsaw on it because, well, everybody likes a robot with a chainsaw, right? But yeah, the idea of these particular robots is to create that advanced path planning or programming for the software, and they can test them in the real world on a real robot, rather than rely on customers having those bad day experiences when the software doesn't work quite as expected. I mentioned 3D printing earlier, and we've got at least one customer who produced parts using robots. In this case, we were doing some of the subtractive elements of those systems, and I'm quite pleased that over the last 12 to 18 months, we've installed 9 systems, milling systems, onto their existing robotic solutions for printing, without setting foot in Los Angeles, which is their base or headquarters. And all of those installations have happened over Zoom, as we are today. not quite, don't cut the red wire, you need to cut the blue wire, but actually we've given them a lot of support and backup, and they're running everything quite successfully actually. So quite happy that you can do international business and support customers over the internet. I did mention a kind of glory shot there for robots with chainsaws, and in this case, the use was a robot in a freezer in Norway for the ice hotel, and they create 2 meter by 1 meter blocks of ice and carve them into penguins and robots, and amongst other things. A lot of that fine sculpture work is done with the robot puts down the chainsaw and picks up a milling spindle, rather than using the chainsaw as the final finishing tool. It's quite rough and aggressive. And there we are for our quick slides and overview of everything from what we've done and kind of how we work from CNC Robotics. I'm going to do a stop share and then kind of bring Michael back in and see if we want to do some Q&A or other chats.
Yeah, I'm here. So obviously we're going to do more of a like fluid, dynamic questions and answer sort of session with obviously Jason and Julia, and obviously feel free to ask any question as broad and as wide range as you can think of, really, in terms of anything to do with manufacturing, robotics, automation, in sort of the CNC sort of world. And we've already got one question from Salim, and obviously he's asking which rocket parts do the robots 3D print? ABM nozzle, hydrazine tank, or every part? Any answer on that?
So quick answer to that, Salim. So the robots actually print the fuselage and the fuel tanks. They don't print the nozzle, or we call it the hot end. They, at least on the robot, but they do print them on other machines, and they often do a powder bed application to print the hot end. Some of the smaller components, you'd imagine, they don't print hoses and that kind of stuff, but there are quite a lot of examples. If you search online for relativity, you'll see actually they print almost everything.
Any more questions from anyone? Yeah, we've got some messages coming in. Mainly to do with the content of the video that's coming through. Apologies for any technical difficulties. Some people are using backgrounds. It's more of a grey, not a purple. But yeah, apologies for any technical difficulties. Coming from Anonymous as well. Do you do much in the nuclear sector, i.e. Sellafield?
I've got the pleasure of visiting Sellafield as well as Capenhurst. The difficulty with an SME working in the nuclear sector is the paperwork and the timescales involved in any nuclear applications. To date, we haven't worked in the nuclear sector. We try and leave those to, we like to call them the big boys. It's often, if we use KUKA as the example, KUKA would take those projects and run with them as a company through KUKA systems, rather than use smaller integrators such as ours. I see one, any project with collaborative robots? No. Collaborative robots and cutting tools is therefore now not a collaborative robot. We tend to use just the hardened version of industrial robots.
Okay, some sectors are looking at reducing demand on the supply chain by additive manufacturing or robotics at some point of consumption. Are you seeing much of this happening?
We're seeing more and more just-in-time manufacturing. we haven't seen any at the point of consumption because we tend to deal with manufacturers, not the end user. The end user being the guy that drives the car or the rocket that flies to space. At the point of consumption, if it was for the general public or the masses, we would say no. We very much work in industry.
Do you work with any institutions, university in your work, i.e. R&D and stuff like that?
Quite a lot, actually. Michael was actually over at Liverpool University only a few weeks ago, helping on the third robot we've installed for them, or second or third robot. Robots are taking quite a commonplace in universities, as you can imagine. The R&D element of robotics is quite high. Yeah, I see more and more robotic applications in universities, and funnily enough, we've just shipped 2 systems out to Dublin University for part of their robotics lab. 2 robots of, I think there's 30 robots going into that that university for what would be Europe's largest robotics facility for education.
Okay. Why did Relativity choose CNC Robotics? What was your USP for that work? Do you have any other space customers for similar remote robotics?
I think I'd like to think, anyway, on a personal note, I'd like to think that our expertise in robotic milling and machining preceded the conversation. I think we like to think that we've got quite a good reputation in the robotics, or at least in the manufacturing world, for providing robots or robotic systems that can drive accurately. And they came to us with, we've heard you guys are good at machining with robots. Can we work together? Other space customers, sadly not, although I have had some conversations with SpaceX and the Northern Space Alliance here in the UK. So fingers crossed, we might do some other work with other companies.
Okay, any more questions from anyone else on? Like I said, they can be as broad and as wide ranging as possible. The whole opportunity is to obviously maximize the information we can give you today. Obviously, we're having an expert in the field of robotics present. And then
I wouldn't say expert. Never say expert. Yeah.
Someone of expertise.
Much better, yeah.
In the field, and we can obviously try your best to answer the questions. Right, okay. Perhaps you could do work for Airbus, Space and Defence, SSTL, Clyde Space, ESA, Harwell.
Yeah, so just
flying cars, Jason. We looked at that for a little.
Flying cars, yeah. We have just finished a defence contract with one customer, and it looks like we'll be doing some more defence contracts. In that case, it was a robot on a 8-meter linear track, a payload of 240 kilograms, machining some parts, of which I can't tell you about. But we also have one customer who's actually they want to provide car taxis. It's called VTOL, and VCRO, and they think they're going to bust the world wide open with car taxis. I think there's still a little bit of time before we're going to start flying around like the Jetsons, but that's not it's not to say it can't be done.
Okay, we got one coming from Matt Rogers. Any projects involving data gathering and analysis, i.e. SCADA, cloud connections?
Yeah, we started a project actually off the back of the Industry 4.0 rush of people doing machine monitoring. We created our own called CNCR Live. Actually, the reality is, if you gather data, that's great. If you don't do anything with the data, it's not worth gathering the data. And I've seen lots of people who have implemented machine monitoring and data analysis tools, but not do any of the analysis and not do any of the work at the back end to do predictive maintenance, for example. Yeah. Force feedback, I see, is a question that's come in. For machining and compensation for accuracy. Short answer is no. The force feedback is quite a difficult and a black art in making robots work particularly well for surface finishes. We have done some work over in 2013 on the Comet project, and you guys can look it up. It's a European funded project on robots, robot accuracy, and this kind of compensation. The short answer was, we can track robots, we can compensate for them, but the system cost just simply wasn't viable as a product. When you compare it to the accuracy you can achieve on a standard milling machine in a volumetric way.
Just answer this one. In aerospace sector, there's a big focus on airworthiness and adherence to some quite strict standards. How easy has it been to demonstrate that the product meets the required safety standards? So, do you want me to do this one for you, Jason?
Yeah, that one depends on what's the product.
Yeah, I'll fly with this one for you. In a sense, obviously, it's a machine supplied no different to a machine tool in most instances. So obviously we can demonstrate part tolerance and part accuracy, and then it would be down to the client, as with buying any other machine tool, i.e. from Mazak, DMG Mori, or Heidenheim, whoever you choose as your favorite CNC machine tool supplier. And then that would be down to their own QA, QI, obviously processes internally to determine whether that part is in with the safety, obviously, standards that they adhere to. Hope that answers your question, Andy. What level of accuracy could?
Yeah, he also asked about accuracy.
Yeah.
Accuracy from a CAD/CAM produced part, we would expect plus or minus 0.2 millimeters, so 200 microns. The repeatability dropping to 0.06, so 60 microns. We have had customers machining parts to 0.05 in the past, and repeatably, so we're quite happy with that. But out of the box, if you run CAD/CAM programs, we would expect plus or minus 0.2 without any offsets.
Smallest part you've ever made, and have you ever made your own drill bits for milling?
No to the drill bits for milling. It's easier just to buy them. And the smallest part would have been a bracelet out of wood, and I made that as a gift to my wife.
Okay.
In the early days, yeah.
Any more questions from people? Here we go. When the CAD/CAM software creates a tool path and then the robot path, does it do the inverse kinematics to get the point angles, or does it produce X, Y, Z, A, B, C, and leave the inverse kinematics to the controller?
So it's the last one. It would
Yeah.
give the X, Y, Z, ABC coordinates and let the robot controller handle
Yeah,
path
so
planning and motion control.
it just boots everything out in Newland, and then the robot does its own kinematic solving. It's all done in Jacobian matrices on a 16 millisecond tick cycle, if you really want to get to the nitty gritty nuts and bolts of it. And then obviously there is loads of extensive research being into trying to close loop that proof and process, where you obviously feed back into the system to try and add inaccuracy, remove the inaccuracies in the kinematic solving based on angular positions and offsets. And then what do you think is the most complicated project so far you've done?
I quite like the one making the carbon fiber tripod legs, where we worked with quite closely with the customer on developing not just the solution to handle and work and manipulate the parts, but we work quite closely with the braiding machine suppliers on how to braid the parts, the infusion process, and about cure time for the infusion, and working with the presses, of which the client, in this case, would pre-issued as part of the project, all the way through to working on the design of the product itself to make the manufacture of the same product more efficient. Often is the case, we get clients and customers come to us with, we already make this product, how can we automate it? But in that case, it was actually, we'd like to design a brand new thing that's never been made. What features do we need to design into it to make it easy to automate or easy to produce from a robotics point of view, not from a traditional manufacturing point of view? So it doesn't seem that complicated from the start, but when you get into that, and that particular project had a £1 million budget and a year assigned to it, and it turned into almost a £3 million budget and almost 3 years worth of work. So actually it became quite a complicated thing, although to the layperson it's just a carbon fiber tripod. There's actually more R&D work and more work that goes into the front end to produce an easy to produce back end.
So all to do with curing times and releasing agents and tool and pressures and weave rates and fiber layups and cold closed mold infusion, and then obviously taking the part straight out and post-processing within seconds becomes quite an intricate process.
Certainly does.
Any more, or I think we've done quite a few questions. As short and sweet as it may be, I don't want to take up everyone's evenings. Obviously, there will be an hour's worth of CPT associated to this event. I'm gonna put my email address into the chat box for everyone as well. Obviously, so if you need any information or any questions regarding getting the CPD certificates, but they obviously will be made available through the communities page on the IET. But obviously, a quick summary of the manufacturing management group. Obviously, we operate in the Merseyside and Western Cheshire area. That obviously reaches as far as Southport, over towards Manchester, Chester, and the Isle of Man. Obviously, we've got 4,000 IET members within that catchment area, and we operate a number of technical groups from the manufacturing management, young professionals, a power group, and some various other groups as well. They have changed recently due to obviously volunteer capacity and changes within industry and trending. Obviously, we've recently joined with the biomedical engineering group as part of the manufacturing and management group to obviously grow the types of events that we can offer to our engineering network. Volunteering is essentially what keeps us going. We wouldn't be able to do what we do and put on the events that we put on without obviously the help and support of the many volunteers that support the local network. So if you are interested in volunteering, again, my email will be in the chat box, and just drop me an email and I'll be happy to answer any questions. But for now, I think we're pretty good with regards to the event, and I'm happy to leave it there. Oh, we got one hand up. That is. Someone raised a hand or got a question? Looks like it. Before we go. Nope. Yeah, no, all gone. So for now, I'm gonna stop recording, and obviously, as I said, any questions, drop me an email, and obviously we'll make the CPD certificates available. But thank you very much for joining today, and obviously thank you for Jason and Julia for giving up your time and obviously speaking to us today.
Well, you guys have a great evening.
Thank you. Thank you so much.